Hello people, welcome back, and today we're going to be looking at practice questions for your paper 2 chemistry, and we're looking at rates of reaction. But before we go through, I just want to say thank you to a couple of these people who actually have subscribed. Thank you very much for subscribing, and I look forward hearing your comments on the videos and questions about your exams. Okay, so let's jump into it.
It was a nightmare.
Activate.
Okay guys, so over here we got our first question. It says pink cobalt compounds react with hydrochloric acid. So you want to make notes of the two things that are reacting together, okay? And the will be your reactants, okay? It says that they will react and they produce a blue cobalt compound plus water, and these are your products, okay? Because this is what's being produced. Now you got to take note to this symbol that is the reversible reaction symbol. So you got to make sure you pay attention to that symbol, okay? The forward reaction is endothermic, okay? So going that way, forward reaction is going to be endothermic, okay? Then it says when both cobalt compounds are present in a solution at equilibrium, the equilibrium mixture is purple, okay? So if you've got too much of this, you're going to be looking at it and it's going to be pink cobalt. If you got too much of that, it's going to be blue cobalt. But if it's in equilibrium, in the middle is balanced, there is the more or less the same amount of each. Might vary by 1 or 2%, then you're gonna see a purple color instead, okay? So first question is what is meant by equilibrium, okay? And this is a 2-mark question, so you gotta talk about two different things. Now at equilibrium, normally things always keep on changing from one side to the other unless you add more reactants, or you add more products, or you heat up the reaction, or the change or something changes, okay? So first of all, for something to be in equilibrium, you gotta mention that it has to be in a closed system, okay? That means there's nothing else being added or taken away, so everything is the way it's meant to be, okay? The rate of the forward and backwards reactions are equal, and this is something very important that you want to take in mind, okay? Because this is always fluctuating, it's always going forward and backwards, but how much goes forward and how much go backwards will determine the color of the whole thing. If you got more of this going forward, the whole thing is going to be blue because you're going to have only a small amount going backwards, and that's going to be the pink one. So overall it's going to be blue. But at equilibrium, it means that the rate of the reaction going forwards and backwards is going to be the same. It's a closed system where the forward and backwards reaction rates are equal. Obviously we're talking about a chemical reaction here, so it would imply that, okay? Now that will give you your 2 marks, okay? Now in the next question, what we got here is that it says that the equilibrium mixture is cooled. Okay, explain what happens to the concentration of the pink cobalt. Now, here's one of the things that we need to remember all the time. When you're looking at an exam question, you gotta make sure you know what is being asked of you. Okay, a lot of the time you will write facts that are true, but it's not what the question is asking you. So you gotta be careful on that. Now, saying to you, explain what happens, right, when you cool the actual the actual reaction. Okay, now, if it's telling us in the question above, over here, tells us that the forward reaction is endothermic. So when the reaction goes that way, okay, so when the reaction goes forward, it's going to be endothermic. When the reaction goes backwards, it's going to be exo, okay? So if the reaction goes out, it's exo, and it goes forwards, it gets cold. So this is going to be cold. Cool was right, cool, and then hot, okay? Going backwards is hot. So it says explain what happens to the concentration of the pink cobalt compound if it mixture is cooled. Okay, now you got to think about, first of all, that energy will travel from the hot substance to the cold substance. Okay, so if you make the surroundings of that reaction cold, the heat energy is going to be leaving the reaction. Okay, heat energy is going to be leaving the reaction. You're cooling it down yourself, okay? Right? So because it's exothermic, energy is given out and it's going to be absorbed by the surroundings. Energy is given by the surroundings. So the colder the surroundings are, the more energy is going to be absorbed, okay? But now it's asking us about the concentration of the pink cobalt, okay? And remember that the pink cobalt is the one that is in this side of the reaction, okay? So the pink cobalt, what's going to happen to the concentration? If you cool it down, the reaction is going to move backwards, okay? So if it moves backwards, when you look at the reaction itself, what do you think is going to happen to that? If the reaction is moving backward and a lot of the products are turning back into the reactants, well, the concentration of the pink compound is actually going to increase. So, okay, pink cobalt concentration increases. As you can see, it's 3 marks. All right. So, so that's going to increase because the reaction is moving to the left side. To the left side, okay, and also energy is being released to the surroundings. There you have it. Now moving on to the next question. Okay, so here we got the next question. It says more hydrochloric acid is added. Okay, so we added more of the hydrochloric acid. So we are actually adding more of the reactants. We increasing the volume of hydrochloric acid being added, and this is part of the reactants. So if you add more of the reactants, what is going to happen? The system itself is going to try to balance it out, okay? And since you add more to the left, more of it is going to be moving to the right, okay? So let's see. If you add more hydrochloric to the what happens to the color of the mixture? So if you got pink in one side with the hydrochloric acid and in the other side you have blue, that means that the more reactants you add, the more products you're going to get. So you would say that the reaction is going to become blue, okay? And that's only 1 mark because the reaction is moving to the right side, because more reactants are being added, is moving to the right side where the products are. So the reaction is going to actually increase in temperature. Okay, no, sorry. The reaction is not going to increase, it's going to decrease, because if it goes forward, if it goes forward, it's going to be endothermic, meaning that it's going to get cooled down, okay? So it's going to cool because it's endothermic. Right, so there you go. So you have your 3 marks. You have your reaction is going to turn blue because the reactants are turning into product because you added more reactants, and the reaction is trying to balance it. So it's trying to find its equilibrium. And then the reaction is going to be moving to the right side, and that is where the products are. Okay, so more products are going to be formed, and this reaction is going to cool because it's an endothermic reaction. It tells you at the beginning of the question that moving to the right side, to the side of the products, is going to be an endothermic reaction. Okay, now it says, why does cobalt form different colors, different color compounds? And this is simple. It's only a 1 mark question. Now remember, the cobalt is a transition metal, so it's going to have different charges, okay? So your answer is because cobalt is a transition metal and it has different charges. There we go. Now it says here, an oxide of cobalt has a formula of CO2 and O3. Which cobalt ion is represented in this oxide? Okay, now this might look a bit difficult, but remember that oxygen is going to be in group 6. Okay, so that means that if it's in group 6, it's going to have 6 electrons in its outer shell, meaning that it needs 2 more negative electrons to turn into 8 electrons. So every oxygen is going to have a charge of 2 minus because they're gaining 2 extra electrons, okay? So if we have 3 oxygens, 2 minus plus another 2 minus, altogether that is 6 minus, but we only have 2 cobalt, okay? Now cobalt, because it have different charges, it has to balance the negatives in order for that to be an actual a stable compound. So really and truly, what we have is that each cobalt that you have there is going to be +3. When you have 2 +3s, you get +6, and then it will cancel that out, meaning that you have a stable compound. So your answer would be this one here, okay? That's your answer. Okay. In this question says cobalt compounds act as catalysts, okay? Which 2 statements about cobalt compounds are correct? They allow reactions to reach equilibrium more quickly. They are reactants in the reactions catalyzed by cobalt compounds. They are used up when acting as catalysts. Well, that's the first thing there. We know that this is definitely a no, because catalysts don't actually take part in the reaction. They increase the equilibrium yield of reactions, or they provide a different reaction pathway. Your answers here, right, is that they allowed the reactions to reach equilibrium faster, and they provide a different pathway. Okay, those are the two things that it does as a catalyst in a reaction. Okay, now we got another question here, and it says the reaction of hydrogen with carbon monoxide. So reactants, hydrogen and carbon monoxide is catalyzed by cobalt metal. Balance the equation for the reaction. Okay, so it's asking us to balance this equation here. Now I have a whole video on how to balance chemical equations, and I'm gonna put a description there so you can click on the link and have a look at it. But essentially, balancing an equation is where you need to count how many atoms you have in each side of the reaction to make sure that you have the same amount of reactants in and the same amount of products going out. Okay, the same amount of each atom. Okay, so the way I tend to do this is that I tend to start with the hydrogens, then I do oxygens, and then I do everything else. Okay. Okay, it's gonna be a bit of a long-winded process, and make the consideration that you only got 1 minute, because, well, normally you're gonna get 1 minute because you want to spend 1 minute per mark. Okay, if you're not really sure, I will leave it and then come back at the end and see whether you have enough time, but it will go something like this. Okay, so I will start first of all with counting the hydrogens. Over here I got 2 hydrogens, over here I got 14 hydrogens in one side, and I got another 2 in the other side. Now you're gonna see why that is important, that you keep them separate. Okay, then I go on to oxygens. I got 1, and then oxygens I got 1, right? So then I'll 1, sorry, there you go, 1 and 1. Then I'm gonna do carbons. Carbons in this side I've only got 1, and then carbons in this one I got 6. Okay, so first of all, I'm going to make the small number equal to the big ones. Over here, if I add those two together, I'm going to have 16. What number can I multiply these two to make it 16? So we're going to go for 8. Okay, so this times 8 equals 16. Now over here, I got 16 already. Carbons, I got oxygens, I got 1, and I got 1, so that's balanced, but the carbons are not balanced. Okay, so what number can I multiply this carbon here to make it 6? So that will be a 6. Okay, carbon is going to be multiplied times 6 to give us 6. Okay, now it's balanced, but because this oxygen is also part of that molecule, is also going to be multiplied times 6. Okay, so over here times 6 equals 6. Now the oxygens are not balanced. Okay, so we got the oxygen 1 here. Okay, so if we multiply that oxygen times 6, now the oxygens are balanced, but because this hydrogen is in the way, that hydrogen is also going to be multiplied times 6, making it 12. So now I've got 14 and 12, which makes a grand total of 26 hydrogens. Now hydrogens are not balanced. Now what number can I multiply that to, right, to make it 26? We do that 13. Okay, so 13, 6, and 6. That is your balance equation for that. Okay, now last question, it says C6H14 is an alkane. Okay, and it's important that you remember that it's an alkane with A-N-E. Okay, what is the formula of an alkane containing 18 hydrogen atoms? Okay, so the way that we work this out is that you gotta remember the formula to calculate the number of carbons and hydrogens, and one other formula of an alkene is, you got C is N, and H is gonna be 2 times N plus 2. Okay, so in this case, we know that the hydrogens is going to be 18. Okay, 18 means that it was N and 2 was added and then plus 2. Okay, so N times 2, right? So that would have been, what number can you multiply times 2 to give you 18? That was going to be that would be 9. Okay, 9 times 2 is 18. So that's not it, because you also added 2. Okay, so that means that that number had to be 16. Okay, so what number can you multiply times 2 to get you 16? That would be 8. Okay, so 8 times 2 is 16, plus 2, 18. Okay, so plus 2. Okay, there we go. So that will be in 2 times 8, and that's going to give you 18. Now, if n is a value of 6, okay, if n is a value of 8, that means that C8H14. And you can do that by doing it like this. So CnH2 times n plus 2. If that was an 8, okay, that would be C8, and that would be 2 times 8 plus 2, which gives you 16, okay, 16 plus 2, that would have been 18 and 8, okay. So the formula for this would be C8H18. That's where you get that from, okay. Now at the back here we got one more question. This is just adding a little bit of energies, right? And looking at endothermic and exothermic reaction. It says the graph shows the reaction profile diagram for the reaction without a catalyst, okay. Draw on the graph, draw the reaction profile diagram for the catalyzed reaction. Draw a label and arrow to show the activation energy for the reaction without a catalyst. Okay, so first we're going to draw the activation energy without the catalyst, and it says that this here is without a catalyst. So if this is the reactant, okay, this here is activation energy, because we know that is the activation energy. Now what a catalyst does, it also reduces the amount of activation energy needed for the reaction. So the reaction profile for without the what's it called, the activation, the catalyst for the activation energy, that means that this slope is just going to be a little lower, okay. That's what that means. So that will be your reaction profile, reaction profile with a catalyst for the activation energy. There we go. And that is your 2 marks right there for a total of 16 marks, okay? Well, there you have it, guys. A couple of practice questions on rates of reaction. If you do have something else that you don't understand, drop it in the comments. If you got any questions, if you find this useful, please give us a thumbs up and subscribe. And remember, the knowledge is power, and I'll see you next time.